Hey guys, today we're going to start chapter 2, and we're going to be talking about relations and functions for a lot of the chapter, especially functions. There's a lot of vocab, so once I get through these objectives, feel free to pause when you need to. So we're going to be asking the question, what is a function? And we're going to demonstrate an understanding of relations by graphing, and also identifying functions by learning the relationship between domain and range, as well as using the vertical line test. So our vocab, a relation is a set of pairs of input and output values. So input values are always x, output are y. The domain is those inputs, those x coordinates, and the range is the outputs or the y coordinates of the ordered pair. A function is a relation in which each element of the domain has exactly one element in the range. So for every x value, there is one and only one y value for it to be a function. And the vertical line test states that if you draw a vertical line, I mean vertical up and down, through a picture on the graph, that there is 1 point on the entire spectrum of the graph. If there's any time that you can draw a line through 2 points, it is not a function. The function rule is just the equation that represents output values in terms of input values. And you can write a function rule in function notation. If you've ever seen f of x equals something, that's the same as y equals something, but all this is saying is it is a function. And the independent variable x represents the input of the function, and the dependent variable f of x or y represents the output of the function. Because what we do when we check to solve these equations, we always put in values for x. So we always make values for that, and what you get for y depends on what you put in for x. Alright, so we have 4 ways to represent relations. We have ordered pairs, so you can write them as x, y. There's a couple examples. You can do what's called a mapping diagram, where you have your inputs and your outputs, and then you draw arrows from your inputs to your outputs. This is good if you just have ordered pairs to make sure that you only have one y value that corresponds with every x value. You can make a table of values, just say input output, or you can make a graph. So here we go. There's 3, negative 4. Here, and 4, 3 is here. So that would be just a graph of them. If it says that it is a function, you probably could draw a line through it.
Mom, what's this?
Alright, so here we go. We have a skydiver that's jumping out of an airplane and experiences free fall. This is on page 61 in your book. You can see the height of the skydiver at different times during a free fall. And if we ignore air resistance, how can we write this relation in 4 different ways? So we have how many points here? 1, 2, 3, 4. We have 5 points. So the first way would be to write these as ordered pairs. So our ordered pairs would be 0, 10,000, 4, 9,744, 8, 8,976, 12, 7,696, and 16, 5,904. Now, why do we do it this way instead of writing it the other way, like 10,000, 0? Because the height at which you are depends on how many seconds you've been in free fall. If you haven't started yet, you're in the airplane, you're at 10,000 feet. The variable that changes is how fast you're falling. Alright, so that was the first way. What was the second way? Well, the second way was to relate inputs to outputs. So we have our inputs, x is 0, 4, 8, 12, 16, and our outputs are 10,000, 9,744, 8,976, 7,696, and 5,904. Now when you put these in order, or when you put these, a lot of times we go increasing order X, increasing order Y. I just went ahead and did them the same. The reason why you do that is so you can make sure you're not doubling up on your answers. So this is actually the third way of the table. So there you go, bonus. So for the second one, we just take and we relate our inputs and our outputs. So you just draw arrows from one to the other. And we see that none of them overlap. So this is a function. And the last way is graphing. So let's see, we only have positive numbers. Okay, so time. We have sections of 4, so 4, 8, 12, 16. I'm going to go ahead and go by, I don't know, what do you think, 2,000 feet? 2, 4, 6, 8, 10. I didn't give myself a lot of room to work. Alright, so then we're going to go ahead and put these dots on there. So 0, 10,000, 4, 9,700, 8, 8,900, 12, 7,600, and 16, 5,900. Okay, so you can see, I didn't do a very good job, but this is a line. It's in constant free fall, so it's going to be connected. You can see that it is a function. Okay, for finding domain and range, all we have to do is find the x values and the y values. Domain is which one? The x ones. So the domain is going to be 0, 4, 8, 12, 16, and my range is going to be the y values, which we've already looked at. Okay, so go ahead and write down domain and range of this one. Alright, so now we're going to look at these and see if they do have a one-to-one correspondence. Does this one, for every x value, is there one and only one y value? Yes, so this would be a function. What about this one? See, this is where we have a lot of numbers. It might come in handy to make that little table. So I'm going to do 1, 4, 4, 6, 8, and -1, -1, 1, 6, 6. So we can already see that we have two x values. So this isn't going to be a function. Okay, using the vertical line test, all we do is we take and we draw vertical lines, and if there's any point where we cross two lines, it is not a function. So here you go, make some vertical lines. If I drew a vertical line right here, it would only cross through one point, but I have all of these points over here where it cross through two. So this one is not a function. Okay, this one. If you draw vertical lines through it, do you ever cross 2 points? No, so it is a function. Oops. This one, it's just dots, but if we draw vertical lines through it, at any point do we cross 2? There is exactly 1 point right there where we cross through 2. So this is not a function. Okay, you go ahead and look at these ones. See what you think. D is not a function, E is not a function, F is a function. Here we go, here's function notation. I'm just going to show you what each one is. The Y is the output, X is your input. It can also be written as f of x because it is a function. And then you can evaluate that function at a single point. So if you put in the variable 1 for the variable x, you can go ahead and solve. So if I say f of x equals 3x plus 2, what I'm saying is it's a function for every value of x. So I'm going to put in a number. So I just evaluate 3 times 1 plus 2, which is 3 plus 2, which is 5. So here you go. I want you to evaluate these this function for these 3 specific inputs. So I have f of negative 3 equals negative 2 times negative 3 plus 5. Negative 2 times negative 3 is positive 6 plus 5 equals 11. You also need to do it at 0. F of 0 equals negative 2 times 0 plus 5. So we have 0 plus 5, which is 5. And my last one, everyone's favorite, fractions. So I have f of 1/4. That's negative 2 times 1/4 plus 5. Negative 2 times 1/4 is negative 1/2 plus 5, which is 4.5, or you can write it as 9/2. Oh, look, there's a pretty table. Okay, go ahead and do this one, see what you get, and I want you to show that to your partner, and have a good day. There's your homework. Oh, man, there's one more. That's just a word problem. Does the same thing. We've already done these. It's okay, don't worry about it. Done.